good afternoon. So welcome to another episode of Liquid Brain. Today we are talking about gganimate in the RStudio environment. Basically, you see the beginning of the video, you know what you can do with animations with R coding. So if you've actually been through the video about ggplot2, you should have an idea of how do you draw a graph in the R environment and how you'll be able to make an amazing graph like a bar chart, a scatter plot and box plot and so on. So what does gganimate do is to add on to that custom already present functionality and take it to the next level, which is make it move. So you can imagine that you add on another variable onto your plot and make them move across the time series as a video. That's basically what it is about. So you can make ggplot2. This should be a little bit of an extension. If you not already know ggplot2, I think you should go into the last video and try to see what you can do over there. So there'll be 5 main topics that I'm going to go through today. So the first is just a general introduction on gganimate packages. The second one is about transition. So transition has many things. They have like transition through time, transition to state, transition through interval, review, and a few things. There are a few examples I'm going to show you afterwards below. So is a static is between each of the transition that you mentioned above. How do you want them to move from one state to another, or one? So basically, how do you want the data to move from the first part of the data point to the last part of the data point, and how it is from one to another, basically, as the name suggests. Second last, you have enter and exit. So there are many ways that you can make the data enter the plot, and you can make the data exit the plot, and you can specify different way of doing it. Fading, appearing, shrinking, and so on. So there are a few animation configuration. And lastly, we're going to show actually how to do the animation that was done in the video, in the earlier part of the video. So basically the bar chart over time using the COVID-19 data that we got from the CDC. So the first one, of course, is how do you use the gganimate package? So of course, go to package manager over here in RStudio, press install, look for gganimate, and you can just install. That's basically it. So gganimate is still in there's a development version of it, but there's also a CRAN version of it. So for newcomer, if you're first time watching this video, I'll recommend it install it directly from CRAN, which is the Comprehensive R Archive Network, and the GitHub version is on the develop. It's still in developer stage, so there might be some bug here and there. So once you can handle the stable version, then you go into the GitHub version. So you can actually just search gganimate GitHub, and there's a very nice description of the whole process over there. Okay, so of course, when you run gganimate, which is through a library functions, I think you know by now library function just includes the package into the current environment, and you usually give you something called a loading required package ggplot2. So make sure you have both installed on your computer, otherwise it will give you an error. So there are a few things in gganimate, as we said just now. There's a transition that you need to do, there's a view which we are not going to go through today, and there's an enter and eat. So we're going to go through individual data set and show you how to draw a few examples using pre-existing data set in R first. So let's go for the easiest one. So the first data set I'm going to show you is actually called iris. So iris data is one of the most common data used in any kind of machine learning tutorials and sample data set and so on. So what does iris data contains is there's 3 types of flower: Sentosa, versicolor, and virginica. So there's 3 different species of flower with variant sepal and petal length and petal width and sepal width. Petal width and so on. So if you plot them on a 2D scatter plot using their petal length and petal width, you can see that they look roughly like this, where one species will be here, another species will be in the middle, and the third species will be on the top right corner of the plot over here. And what we want to do now is that we have done the plot through a ggplot and geopoint. Fairly straightforward. So what we do is that using another parameter, so you can see we're using petal width and petal length over here. What we want to add is to use the species to do the transition in between them. So which is why we add on another function called the transition state. So transition states mean we are transition in between three different states because there are three different species over here. Okay, so the transition length is the time of the transition from one state to another, while state length is how long do you want to stay in each of the transition. So similar to ggplot2, you can run the whole thing here and then pipe it into another object called any. So in this case, the any actually contain a lot of information about the data layers, mapping, ease, transmute, and so on. So how do you view the graph is that if you do not want to change the parameter of the animation, you can just type ANIM, press enter. That should bring you to a rendering page. So of course the default way of animation actually have 100 frames at 10 frames per second. So you should have a 10-second video of the output basically. So in transition state, there are also three things: the state, which is the species, which is the variable you want to use for the animation. The transition length, of course, like I said, it will be the relative length of transition, while state length will be the relatively length of the pause. So in this case, you can see this is the first species, the second species, and the third species. So I think I'm blocking one of the animation. Let's play it again. Okay, so this is the first species, and it transitions into a second species, kind of seamlessly, where you move the data in between, and it go into the third species as seen over here. So this is one of the way of how you can really get started on gganimate. Then we go into a little bit more function and a little bit more complexity onto the thing that we have done just now. So we have talked about is a static. One of the thing earlier is basically just control the easing of a static. So you can see there's three state over here. So this is what we call a linear easing. So from one state to a second state to a third stage, the speed of change in between them are constant. So they're just slowly moving from one state to another, to another, to another, to another. So that's what we call linear, which is the default way of doing the easing. Okay, so of course there are many things that you can do. One of the funny one is called a bounce out. So bounce means you want the thing to data point to bounce around in between the stage, and out is actually for here. So the easing function is applied in reverse. So the easing function apply as it is, out in out is so on. So you can actually use the combination of all this. Actually, I should just do this a little bit so you can see that this is the easy type, and there's quadratic, cubic, quintic, sine, circular exponent, elastic, back, and bounce. And once you do the animation type, you also define the animation modifier. So this will complete the aesthetic for the way. Okay, so for bounce, you can actually see from the first stage, it will bounce a little bit to go to the second, and it will bounce a little bit again to go to the third one. So is aesthetic just define how it moves in between the stage. So of course, in most of the time, it's not that straightforward to understand, which species are we looking at, which frame are we looking on, which is why we usually run a title and subtitle. So in order to display the different state and different time point and different frames, you use this close and open bracket, where you actually define here is a closest state. The closest state here only applies to transition state. So just so you understand, so that you will actually show the current stage of the animation it is based on the closest state that it is. Kind of self-explanatory. So you can see when the video started, we are in our Sentosa. You can see the species Sentosa are all clustered around here. And when it when you do the transition, you slowly change to versicolor and slowly change it to Virginica, where you will be able to see how it functions from the first frame to the 100th frame and so on. Okay, so of course the frame of n frame makes sense, the current frame and the total number of frame within the animation. Okay, so once we are done, let's go to the next one, which is the enter and exit animation. In many ways, you can't actually do direct transition between one state and another. Let's say if I add a color into geom point, so let's just try the second animation over here. So in this case, if I just run this, let me just show you this. So if I just run the data itself without the transition, you can see that on top of the plot just now, we have added the color into the current canvas. The problem is that now you added another variable in. The way the gganimate get a little bit confused on how should I transition from one to another. Yeah, so it got a little bit confused on how do I transition from another now then for the color. So they're a little bit confused on all this thing. So you can still use transition state as the way of transition, but the problem is that it will not transition properly. Let me show you all this thing. So obviously you added something else that it would take a little bit longer to render, and they're a little bit confused on how it works. So let's just wait for the thing to finish. Yeah, this awkward silence in the middle of the video, isn't it? Okay, done. So as you can see now, they don't know how to transition because there's added parameters in between them. They don't know how to change the color and so on. So they're a little bit confused. So in this case, it's most likely that you can't just transition from one to another directly, where the states are so different. You need to redefine the way that you do exit and exit, enter and exit function. So this is what divs come in. So in this case, we have an object that contains all the drawing animation just now. What we add here is actually an enter command and an exit command. So this will determine how the point would enter into the canvas over here and exit the canvas. So you can see that you just use enter and exit, and the one in the back, actually you can go into the website attached here to try to see. There's many different combinations that you can put in. So they're using fade as the entrance and string as the exit, which means that you should be able to see here that the data are faded into the canvas, and when they exit, the data is going to string. So you can actually see that the data actually fade into the canvas and slowly shrink it out. And of course, if you don't think that's easy enough to see, you can actually add a drift. So enter, you can actually stack onto one another. You can add a fade and the drift at the same time. So X mod means that they're moving in the X directions with the X modifier and so on. So try to change it around. That's the easiest way to understand what everything does. Well, it takes quite some time to render. Nothing we can do about that. Okay, so once this has finished render, you can see it actually drift in while fading, and then when it drift out, it actually strings. So this will actually make a very well communicated idea that these are three different species, and these are how they appear on a graph. Okay, so now let's combine all that we know. So we have done a few things. The first thing is the transition state. So we have used transition state to transition from one to another. We also do is a static, how they actually behave in between the transition. We have done the animation, the title and the subtitle, and we have done the enter exit animation. So if we just combine everything, so it will roughly look like this. So you might say that wait a minute. So there's a static of sign in and out, but there's an enter and fade. So what they do is that there's actually something invisible inside the gganimate code where they'll determine which one is the possible one to be done onto your data set. And if it doesn't work, try to change a few things around and see how it works. So there's gganimate itself, the source code is quite complicated, and I'm not really qualified to talk about it here. But you can try to remove this and see how it actually affects your graph in a certain way. And most likely depends on how do you define your raw data as well as the genome plot over here. So you can see in this case, we're using a data called empty cars, which actually I talked about in the last video. Is about a collection of different cars. Actually, let me show you if I have a data set here. I don't have. Okay, so for empty cars, it's actually just a collection of cars. There's 32 different cars and 11 different types. There's I'm just focused on what we have here, which is miles per gallon, is how fuel efficient it is. We have cylinder, if I'm not wrong. Yeah, we have the number of cylinder in a car, as well as what's the last one? MPG, and we have the gear. So the gear means how many gears do you have in your car. So usually automatic car has about 3 to 4, manual has about 5, and some supercars has about 8 to 11, and so on. Okay, so you can actually see the animation over here. The lower number of, I hate this thing. Okay, so the lower number of cylinder a car has usually result in a higher MPG. So that's actually quite general across So quite a general trend across the data set. But when we run through the different gears, you realize that the more number of gears in car with 4-cylinder, it is a lot more fuel efficient. But in the same time, it doesn't apply to every car. It only applies to certain car, and in certain ways, in general, the more gears will result in a better fuel economy in cars with 4-cylinder and so on. So you can see how we have plot the cars, and we have the factor. We have the cylinder and MPG on the graph, which is the cylinder as x-axis, MPG as a y-axis, and we are transitioning through the gear. So there's 1, 2, 3 different parameters on one graph itself. So that's how you add what I mean of adding dimensionality into your plot and try to tell a story about it. Okay, as you can see, enter and exit doesn't really make a difference here because it's not needed. But the sign in and out, actually, you can see that the changes are not linear. They are like, and then they slow down. So that's kind of the meaning of sign in and sign out, basically. Okay, so the second example, we have to install another data set called gganimate. So gganimate is actually very famous by one of my favorite scientists that I forgot the name about. Something Rosling, Hans Rosling Getz. So it's one of his famous work about this one. So to install gganimate, just do that. Just install the gganimate, press install. That will give you the data set. And to load the data set in, you just put a library gganimate that will load the data set into your library or environment. Okay, so this is a little bit more fancy. So what they do is that they're using gganimate dataset. So there's 4 different parameters already defined in the data itself. So the x-axis will be the GDP per capita, which is a measure of how rich a country is. Y is the life expectancy of the population. The population size of the overall country will be the size of the bubble over here, while the color represent the country. Okay, so these are like 100 different countries over here. And what they do during the transition is that they use a transition time where the plots are going through a series of time or going through different timing. Yeah, progress to different time will be a good terms over here, and the title will be the frame time. Okay, so as you can see from the thing here, this is actually started from 1952, and you can see that all of the country have a general trend of, when their GDP is going up, you can actually expect increase in their life expectancy. So this happens across the year, where in the last 50 years, we can actually seems to have a general trend in most of the country where they have an increase in GDP as well as a life expectancy. So you can kind of tell people that GDP is directly or somewhat correlated to life expectancy through many factors and so on. So this is how you tell a story through time using 5 dimensions onto a single plot. So GDP 2, 3, 4, 5. So that's how you can add more dimension into it. Okay, so let's now actually go into the COVID-19 data set. So the problem is that just like every data scientist in the world, we spend 80% trying to modify, clean up, and massage the data, and 20% actually complain about it. So even though gganimate and ggplot itself is extremely easy to use, you kind of need to do some, what's that called? Data modification, calculation, summarization to actually get what you actually want to plot on your graph. Okay, so what we do is that the data is actually downloaded from this EU CDC. So that has the new cases found new cases reported in every country from December through yesterday, which is like 20th of April or 19th of April, time zone and so on. So what I do is that I downloaded the Excel file from the website, and I use a rich Excel format to pipe it into an object called COVID-19, which actually you can see over here. So this is actually a data frame with 10 variables, the date of reporting, the cases, death, country, and so on. So there's 11,768 total entries overall, and you can see that it consists of many countries. So what is important over here is first one, the data reported, the date reported, which we really need to know because we are progressing through time. This is the overall concept of what we want to plot. Date, month, year kind of redundant to the date reported. We're not really gonna look at them. Number of cases, definitely something important. Number of death, very important. The country are very important, and the country code and geo ID is kind of the same with the country. And the population, even though useful, we're not really gonna calculate it here because it's kind of makes things a little bit too complicated. So what we're gonna focus on is the date of reporting, the number of cases, the death, and the country. So these are the 4 parameters. So the first thing that I usually do, of course, is to look at the dimension, look at the structure, basic thing. If RStudio, of course, you can click and open it. But these are still a relatively small data set that you can still open it in the viewer. And when you have a much bigger data set, you have a lot of trouble, let's say, scrolling through the data set, where it's just really difficult to visualize. So the structure command gives you a really nice overview of like this one is the data type, which is a time format. This is a number, this is character. So it's very easy to know if you want to, let's say, convert one of the countries to factors, convert the year to factors, and so on. So if you do want to do any downstream data manipulation for to plot the correct data, a structure is a way easier way to do it compared to just click on the viewer. So we're going to employ another one of another package called dplyr. Again, if you want to install it, just go here and type dplyr and install. Very easy. So what does dplyr do is that it allows you to quickly and easily mutate, filter, summarize data. Okay, so how does it work is that you put your data here and you run the command through a pipe. So in this case, the symbol over here is a piping symbol. So what does this do is that they will take this data and they'll group by the country and territories. As you can see, this is one of the variable over here. So they'll group by this and they summarize based on the cases, which is the sum of all the cases. So what does this is that they will give us a table called total case in all countries. Let's go in here. You can actually see there's 206 different countries and there's 2 columns. The first is the name of the country. Second is the total number of cases add up in all of the days in the last 4 months, basically. So if you sort by case over here, you can say USA has the highest number of cases among all the countries in the world. USA number 1, followed by Spain, Italy, Germany, UK, France, China, Turkey, Iran, and so on. So the first thing usually we do in data science is that we do not want to plot everything out. It's very confusing. So we usually get the most significant one to actually plot into the data later, so that we don't run the problem where there's a lot of wasted country. I wouldn't say wasted country, but let's say you include all the data like Mauritius, Greenland and Guyana. It doesn't really show up in your plot and they take up space. So we only want to plot those that are really significant and are having a lot of problem in their country from COVID-19. So I would suggest maybe just set a random or kind of arbitrary cutoff point of 30,000 where we can include the 14 most affected country in the world to proceed forward with the plotting. So in this case, this will do roughly the same thing. It will group by the countries and filter based on if the summary are more than 30,000. So we'll actually pipe this into an object called COVID-19s, which is a shorter version of the original, and we'll actually filter based on date so that we do not, since there are very little number of cases since last December, so we don't really want to look at those it's 5-10 cases. Doesn't really make a difference, so we usually cut them out. So and we only start early this year, so we'll take the data for 1st of January until 19th of April. So this will depend on when you download the data and what kind of filtering do you want to do beforehand. Okay, so what we do next is that we are trying to calculate the cumulative cases and death, because every day new cases is not a really good representation of how severe is the situation and what have happened in the past. It doesn't really tell us that. For the way of visualizing a total number of cases across time, I think you can actually look at my previous video in ggplot2, where we already plot an area or line graph that actually show the progression through time in that 14 different country. So in this case, we want to calculate the cumulative number of deaths and cumulative number of cases in the country. Okay, so these two will accomplish that. Finally, we want to calculate the total death rate. Just a rough estimate is not a super good way of calculating because certain people recovered, but they are not calculated over here. So what we're going to do is just take the cumulative number of cases and use that as a total number, and we'll use the cumulative death divided by cumulative cases times 100. So that will give us a percentage of how many people of that infected population have died because of the disease and so on. So that will give us a rough idea of the death rate. But because the country have 0, we need to, this is just a normal data cleaning stuff, because if you go in now, you actually see the death rate have like 0, 0, 0, 0, and there's sometimes some funny numbers that we want to get rid of. So they're not present here, which is great. But I'm just going to show you how anyway. So what does this do is that every time a data is show up as NaN, which is not applicable, not number, or let's say you divide by 0, they don't understand, they'll give an NaN, or you try to square root a negative number, they don't understand, they'll give an NaN as well. So what we do is that if there's a calculation error, we want it to be 0, so we can ignore them in the thing later. So if they are infinite value, such as like divide by 0, that's an infinite value, also change to 0, it's not relevant. Also if the death rate is more than 20%, we also want to ignore that, because those are usually early stages of a disease progression where there's only, let's say, 5 people in the country got infected and 2 of them died. So that's a 40% death rate, but it doesn't really represent a real situation over here because of how small the sample size is. So anything above 20%, we just cut it off and call it as 0 and just ignore them when we are plotting the thing. So the next one is very complicated. I will show you why later. It's basically converting the countries into individual factors and arrange them based on the cumulative sum cases, so that it arranged nicely. You see what happened later when I show the graph over to you. So for this one, same. So we'll be plotting 2 different types over here. So the first, just try to show you how to use transition review and transition time. So let's go for the first one. So the first one is it's just the same thing. We are plotting cumulative number of cases versus cumulative number of deaths. So the way of progression will let you know that if a situation in COVID-19 actually caused any death, or it's just a lot of infection. Let's actually explain it when we actually got the thing. So before that, actually you can see this is before the animation, this will roughly looks like this. So you can see one country over here has a significant high number of cases versus death, while the other country are slightly steeper over here. So in this case, it means that there's more death per case compared to this country, where there's just a lot of cases but no death at all, which is interesting. So let's go for transition review. So what the difference between transition time, state, and manual is that transition review will actually retain the data in the past. So you are so you are progressing through 300 days over here. Transition review would not delete the data when it showed the next one. So remember the transition state as above, where we show the data for versicolor, the data for the other 2 are gone, they are not shown on the plot. So transition review will try to retain all the data and give you a progression on how it slowly works out. I'm not sure it will work. Sometimes every time I try to run it with a camera on and it doesn't work. Let's see. Okay, so as you can see the graph over here, you can see that the thing has slowly growing. So that's China, and you can see the other countries slowly catching up with the curve and so on. So it's not a really good way of doing things. I think there's still some problem with the program, but you're not here for this one. This is not very useful, and yeah, it doesn't really tell a story in any certain way. So what I really want to show you is the next one, which is the column chart that you see in the beginning of the video. So in this case, we are piping it through what is that called, an object called CV3, and we're using country and territories as our x-axis, and we're using y as a cumulative, y for the cumulative number of cases in the country. And what we do is we pipe it over to an object called CV4. So before we do that, let's actually go into just plotting the graph first. So this is roughly how it will look like before you send it through into rendering, because rendering takes a lot of time. So what does this do is that geom column, the ggplot itself define the data and the static. Geom column actually just plot it as a column graph. I think that's easy enough. While the aesthetic field equals to the depth rate. So the darker the color, the lower the number of depth rate. So the white color one is the one you need to worry, like Italy has a really high depth rate, or France has a really high depth rate, and so on and so forth. So coordinate flip means it will flip the x and y axis, so that instead of getting a vertical column chart, you get a horizontal one. So let's actually send it through the object and let's run the animation. So because of the relatively longer period of time, I'm running it through a longer time frame. In this case, we have 240 frame in total, and we're using an FPS of 18. So there's 18 frames per second. So you can actually divide the two to find out how long the duration will be for the plot itself. And I'm running out of breath because I've been talking for half an hour. So estimated another 13 seconds. We will see. 7, 6, 5, 4. I'm quite nervous because I don't know if it will work. Just like the one just now, it just doesn't work sometimes. We don't know what happened. It's okay, 35%, 45%. Oh, it's getting interesting, isn't it? It's getting intense. It's getting interesting. 87%, 95%, 99%. Now we got a video. Oh, luckily it works. So this is combining everything that we know about the whole GG animation and try to use a little of data, massaging, understanding, and so on. So you can realize that the curve doesn't exactly look like the last one that I plotted out here. It doesn't save it, is it? No, it's here. So it doesn't, because this is on a linear plot, while the newer one actually I plot it on a log scale, because it can visualize the data better. And because of the frame per second and number of frame, we end up in 13 seconds video. So let me just go through the video with you. So they're showing the GG title over here will show the frame time, which actually will show you the exact date of the plotting, and the subtitle will show how many frames and the total number of frames and so on. And so you can see, let's see, so in early January, there's only like a few thousand cases in China, and that actually slowly increased to more than 70 and 80,000 in China in February. In February, they actually go to 80,000 over here, and it's actually stabilized that. So China is now kind of clear of COVID-19 situation, and they're opening back up, while the rest of the country just started to have all the data at around end of February and beginning of March. And as you can see, initially Turkey has nothing, Russia has nothing, Brazil has very little, United States it's quite bad, but not as bad as, let's say, Italy and so on. And you can see USA is very, very quickly catching up to the rest of the country, while France actually slowly catching up the death rate. So we are not too sure about the exact death rate on other countries, let's say like USA, Germany, and Turkey yet, because they're still relatively new. And it might take time for an infected to actually die from the infection. So it will take some time before we understand. But just by looking at the graph itself, we can kind of understand the progression of the disease through time over the last 4 months. And that's basically the power of doing an animation. There's a lot more fancy thing you can do, but more importantly, I always want to tell people that before you try to demonstrate your skill, try to understand how you should be able to tell a story with your data. Okay, so that actually brings us to the recapping time. So let's go through our 5 points that I will go through today. So initially, I just talked about the basic in gganimate packages in RStudio. How do you install them? How do you load them into environment? So second, we talk about transition, which is how after you plot a graph, what variable do you want to make the animation? So what variable do you want it as the time dimension, basically? So there are transition manual, transition time, transition review, transition there are many types of transition that you can look, and it depends on the context of your data to see which one to use. There's no best way to do it. And the third one is actually the easing of a static. So it can be bouncy, it can be a sine curve, it can be linear, and it depends. It's just you can control how do you want the animation to go from one state to another. And again, there's no correct way, depends on how you want to tell your story. And the fourth one is actually the enter and exit animation. How do you want the data to come into it? If, of course, the data itself is not directly or immediately transmutable, they can't transmute from one state to another, like the iris data over here below, where you can't just transmute from one to another. You need an enter and exit animation to tell specifically how you want them to interact and how you want them to display. And many type of things you can actually, there are many combination you can put in this side, and you can stack one enter on top of the other enter. And lastly is the COVID-19 data animation. So from using a data from the CDC, this is just basically just a simple way of how you can plot the situation over time and how you can visualize the data over as it happens, basically. So actually I forgot to come back here and explain this. So what does this do is to actually arrange the factor, which is the country over here, from the worst to the least in the, it's, when I say the best, it's still like quite bad. So USA has the highest number, Netherlands has a least number in this list, basically. So this will actually try to rearrange them, so when you plot them out, they can appear in the correct order. So best, I think that's close up what I need to say for GG animation. I hope that you can find all the coding I have in the description down below. We will bring you to a website, and that will have all the script that I have. You can download, try it on your computer, and change as much parameter as you can to see what does it do. That will be the best way of learning this. I don't have anything else. I don't know, like, subscribe, and comment, and thumbs up, something, notification bell. Bye, enjoy your RStudio, and see you next week.